So somebody wanted to know about transsynaptic retrograde degeneration and how that can be helpful in neuro-ophthalmology. And when we have retrograde degeneration, what that means is the axon of the neuron has been cut. And so when you have a damage to the axon, it will die back to the cell body and will die forward as well. So we have both anterograde and retrograde degeneration of this axon. And what that means for us clinically is we can see optic atrophy in the eye even though the lesion is intracranial. So when we look in the back of the eye and we can see the optic nerve, we can see that there's nerve pallor even if the lesion is way intracranial. And that's because the axon for this retinal ganglion cell travels in the optic nerve, crosses in the chiasm, it goes to the geniculate body, and then becomes the optic radiations to the cortex. So any lesion in front of the cell body at the level of the lateral geniculate body all the way to the eye can produce optic atrophy. And the same in the eye. If you have a retinal lesion, like a retinal artery occlusion, you'll get optic atrophy. That is anterograde optic atrophy. But any lesion from the geniculate body back to the eye is a retrograde degeneration. And so they both cause optic atrophy. One is anterograde Wallerian degeneration, and the other is retrograde. However, the cell body is in the geniculate body, so lesions behind the geniculate body do not normally cause optic atrophy. However, sometimes, especially in utero events or congenital lesions, you can have an occipital lobe lesion that jumps the synapse and still shows up in the eye. And that thing is called transsynaptic because it jumped the synapse. So transsynaptic degeneration occurs rarely in adults. However, it occurs in utero, congenital, or forming brains. So in utero infarct can cause this, even though it's occipital. It'll cause optic atrophy. And we can see this on machines, even if we can't see it ophthalmoscopically. So even if we don't see the optic atrophy, the macular ganglion cell layer sometimes shows transsynaptic degeneration after occipital lesions or radiation lesions in adults. And so you should know that most of the time it is retrograde degeneration that we see in the optic nerve as optic atrophy, and rarely it's transsynaptic. When it is transsynaptic, it's usually a kid with an in utero event, but it can be seen in adults as an acquired basis, but it normally takes that machine to see it, the macular ganglion cell, OCT.